So in this session, I will talk a little about different approaches for reading data from different types of sources, right? So uh, there are two types of data sources for Spark. The first type is known as data files or some data sources that are implicitly supported by Spark. Right. So mainly we categorize into three categories. The first one is your data files. Your data is already there in files within your data engineering platform, and you want to read it and create a data frame and then start processing it. So that's the first thing we do. The second type of source is your database tables. When we say database tables, I'm talking about within your data engineering platform, like a Spark database or Hive database, or database and tables created within the data engineering platform itself. We are not talking about the external sources, which are outside the data platform. And then third type of source is your external systems. It could be anything. The list for external systems is huge. It could be relational databases sitting outside your data engineering platform. It could be, for example, NoSQL databases like Cassandra DB or MongoDB. I've not listed other things, but there are a huge list of things, external sources from where you may have to collect data, bring it into data engineering platform and process it. So Spark supports a huge list of external sources also. But in today's session, we want to talk specifically only about file formats, how to read data from different types of data files, right? So Spark is known to be a unified system for doing many things, right? When we say unified system, it basically means one system, one approach, one set of APIs for doing multiple things or different types of things, like one system for doing batch processing, stream processing, machine learning, running SQL, and doing graph processing, all that on a single system. And that's why they call Spark as a unified system. That unified approach is taken deep down in the Spark itself. So when we want to read data from external sources or internal sources or from data files, the API for data for reading data is also unified. So we have one single API, one single approach for reading data from anywhere, anything and everything that Spark supports. How? That's what I want to explain here in today's session, and give you some examples. So DataFrame, reading data in Spark is done through DataFrame Reader API. And how do you get DataFrame Reader API? Is Spark session dot read. This attribute gives you a DataFrame Reader object. And once you have DataFrame Reader object, you can supply you can execute different kind of methods on the DataFrame Reader API to define how to read data and from where to read data. And then DataFrame Reader API will read the data, give you a data frame. That's a standard method used across all kind of sources, and we will show you some of those. So general structure for reading data in Spark is using DataFrame Reader, and then you have bunch of methods, and this is an example for using those methods. The most important methods for DataFrame Reader are the format method. Almost always the first thing is to tell DataFrame Reader that what is the format of the data. Format could be file type like CSV, could be JSON file, could be Parquet file, could be XML file, could be simple plain text file, could be JDBC connection to a relational database. It could be Cassandra, if you are reading data from Cassandra. It could be MongoDB, if you are reading data from MongoDB. The point is the format is the key to tell DataFrame Reader that how to read data, what is the data format, from where data is coming, right? So you tell that using the format, and then you have option method, which allows you to provide additional details about reading data. For example, if you are reading CSV format data from a file, you can tell some options like, okay, in the CSV file, there is first row is a header row. So we tell that option is header equal to true, right? So like that, there are many options supported by Spark based on the format. For each format, there are different kind of options supported. So we will learn all that slowly. But as of now, what I want to help you understand is how to read data. And this is your standardized or unified approach for reading data using the DataFrame Reader. I'll show you some examples, which then it will make more sense. But then there are some shortcut methods. This is the standard method. But there are some shortcut methods, like you have some shortcut APIs. Like if you want to read CSV file, then you can simply use spark.read.csv instead of format and options and all that. You can use a shortcut method, which is .csv, and within the shortcut methods, you provide all the details, like what is your source, do you have header, do you want to automatically infer the schema from the CSV data. All those you can provide. We don't recommend using shortcut methods. Reason is we always try to write a standardized code or follow a standard approach, which is known and understood by everyone, right? So tricks and shortcuts and all those are not considered good programming practice. And that's why we don't recommend using shortcut methods. We recommend always use the unified data frame reader approach for reading data. Even if you want to read directly data from files using CSV, using SQL also supports you reading data from different kinds of data files. We will see an example, but this is also a kind of shortcut method used in Spark SQL. So with that context, let's go to the Databricks environment and okay. So with that context set, let's try to see a few things in action and try to understand it in more detail. So I have this notebook. Let me attach it to a running cluster. Okay. I started one cluster. What? Didn't I start? Oops. Okay. So looks like we have to wait a few minutes to start a cluster, but that's fine. We can start talking about the example. So let's assume I have a file. It's inside my data engineering platform. The file is stored in the DBFS. DBFS is a Databricks file system. At very high level, as of now, you can think of it like HDFS, Hadoop distributed file system. Similar to that, Databricks has developed DBFS, which is known as Databricks file system. So, but more on DBFS we will learn when we start learning Databricks. But as of now, you can think of it a file system where you can create directories and have some data files. So I already have a data file in the DBFS. File store rental is the directory and actor.csv is a data file. A notebook allows me to run a magic command, %fs magic command to see few lines from the top of the file. So I've executed that and you can see the content, right? So let's assume you have a file. It's a CSV file, actor.csv. This file doesn't have any header row. We have comma separated data. How do you read that in Spark and create a data frame out of it? That's what we want to learn. And I already mentioned there is a unified way to do it using DataFrame Reader API. I have one more example. This is also a CSV file, which is a little different than the earlier one. In this CSV file, I have one first row is a list of column names, right? Invoice number, stock code, description. So this is a header row. And then we have data. It is also a CSV file. So how do we read a data file, a CSV data file without header? How do we read a CSV data file with header? There are two variations. For reading data, we already know that this is the simple code. You start with the spark.read, and then you tell the format in the data frame reader. So let me open the documentation. I can help you a few things with the documentation. I'll go to the API doc. And in the Spark session, we know that spark.read is the unified way for reading data from anywhere. That is supported by Spark. And Spark read gives us a data frame reader. And then once we have the data frame reader, all the methods are defined on the data frame reader. So that's what we will do. Spark.read to get the data frame reader. And then I have to tell what is my format. So format is CSV. So I'm telling that format CSV. And then from where to load that data. So in the load, I'm telling the file location. You can tell only directory location here. But if you tell only directory location, then all the files in that directory will be picked up by the Spark, right? But if you tell only a specific file name, then it will read only that file. And that's all. You can run it. So if I run it, I'll read the data from here and create a data frame, and then I can use the display function. Display function is a Databricks function. It is not an Apache Spark function. So display function, you can pass a data frame in the display function, and it will display it in a nice way. So otherwise, you can use this dataframe.show method. So that also displays. But dataframe.show, this you can see it displaying like a table in a nice formatted way. So that's the benefit of using display function. So you can see this is my file. What I'm doing is I'm reading this data from the file. There is no header information, nothing. So we know the column separator is comma. So it's a comma separated file. So we tell that, okay, format is CSV, load it from here and show us, display that. So if I display, then you can see the column names are default automatically picked up by Spark. Because for creating a data frame, you need to have some column names. There are no column names defined in the file, so Spark will automatically give some default column name, underscore C0, C1, C2, C3, C4, like that. Whatever columns are there, it will be picked. If you want to give explicitly a column name, you can apply some transformation here. Like .select expr is one transformation, similar to Spark SQL select. And in the select, you can tell, okay, first column, what all you want to select, the first column, second column, third, and fourth. And it is basically as underscore C0 as ID, but as is optional, so we don't use it. C0 as ID, underscore C1 as name, C2 as address, C3 as DOB. And if I run it again like this, then CSVDF is a data frame which will be created. Now you can see the column names are assigned here, right? So that's how we can read CSV. The point is, okay, the point is that CSV is one format which is not for comma separated values. It is a format for any delimited file. So even if I have this data file where I have delimiter is comma, column delimiter is comma, but even if it is like some other symbol, I can read it using CSV format only. CSV format, though the name is CSV, but it is not only for comma separated values. It is for any delimited file. You have colon delimiter, you have pipe delimiter, you have hash delimiter, whatever is there, you can read all those, but you have to tell data frame reader that what is the delimiter. Default is comma, right? So we have one more file, this file comes with the header, right? So in this file, first row is header. How do I read this file? Method is same. First thing that I told you, that reading any data source, method is same. Use spark.read. Spark.read format CSV. Let's say I'm not telling this. I'm simply reading from the source, right? So what will happen? I'm telling what I'm doing here. Spark.read means I'm getting a Spark data frame reader, then telling read the data, format is CSV, and load it from here. Only two things I'm telling, and then I create a data frame and then display it. So what it will do? Okay. Good point that I wanted to highlight here. In Python, if we want to do a line continuation, we have to keep on using this, right? This slash. So that's a Python language thing. Otherwise, this code can be written actually like this: spark.read.format, right? And then maybe .load directly here, right? But for a better visualization or for better formatting, we normally do it like this: spark.read and then new line, and then maybe like this. So slash is your line separator or line continuation in Python. That's why you will see everywhere this slash. But this thing sometimes it is irritating. So how you can avoid that? And sometimes if you put comments in between, then still that line continuation it throws an error. So how to avoid line continuation? You can use something like that. Put an extra parenthesis at the beginning, at the end. Maybe you can format it like this, and then you don't need all these garbage or line continuation. And then even if you put some comments in between, it will work. So a lot of people follow this practice instead of that. Well, let me run this. Here I've written using that same way, without line continuation, putting a parenthesis at the beginning and end. And that's how Python will know, okay, your line starts from here and ends here. So everything in this is a single statement. I don't have to tell line continuation. Okay, so this is how I'm reading it. I'm using a spark.read, format CSV, load it from here. And I'm not telling that first row is a header row. So what Spark will do? Spark will read everything. It will read this row also. Everything it will read, everything it will consider as a data. And that's what you can see. Even the first row is coming as here as a row. So Spark consider it as a data. The point that I want to highlight here is that with the data frame reader, once you do a spark.read, with the data frame reader, you will tell format. And sometimes that is enough, but sometimes just telling format is not enough. To correctly read the data, you have to tell more information to the Spark data frame reader about your data set so that it can read it correctly. For example, in this example, I'm reading a CSV file which comes with header and it is reading correctly, but it is not matching my expectation. I wanted Spark to eliminate this first row from the data set and use these names as a column name. But for that, I have to tell Spark that, okay, some additional information I have to tell Spark, and that additional information is there is a header row in the file. So you make use of the header row. So if I tell that option here, Spark will read it correctly. You can see header row is gone from here and it is used to create the data frame column name, right? So the point is, for every format, there are some options to tell additional information to the data frame reader that how you want to read the data. Right. So, and those or additional options you will not find in the API documentation. You have to come to Spark SQL DataFrame dataset, and you will see data sources here. And then you can see a list of data sources that are implicitly supported by Spark. There is a huge list beyond this. All that data sources are supported by Spark, but not implicitly. Those are you need some additional package installation to read data from those sources. I'll show you one today itself. So these are the data sources that are implicitly supported by Spark: Parquet file, ORC file, JSON file, CSV file, plain text file, Hive tables, JDBC database, Avro file, protobuf, binary file. All these are implicitly supported by Spark, and we call them connectors. So these are implicitly supported connectors for reading data from the source. We have a Parquet file connector inbuilt in Spark, ORC file connector inbuilt in Spark, JSON file connector inbuilt in Spark, and each connector comes with its own set of options. Like if you go to the CSV file, you scroll down, you can see the list of options, right? SEP, one option, it tells what is the column delimiter, right? If your file is Unicode encoding, it's UTF-8 encoding by default, but if you have a file which comes in some different character encoding, you can change that. All right. So like that, you have a lot of options here, and the entire list of supported options is here in the documentation. I cannot explain all that, but time to time we will be using many of those, and you will keep on learning. We use the header option. By default, it is false. But if my file comes with the header, I will tell header option header equal to true, like I have done here. I can tell if my file is comma delimited, I don't need to tell the separator option. The first one here, because default is comma. But if it is not comma delimited, if it is like, suppose my file comes with some pipe delimiter or maybe something like this, colon delimiter, I can read using the CSV connector itself, telling the separator. But since it is comma delimiter, I can tell comma, but that's not required because that's the default, right? So the point is, DataFrame reader allows you to read data from any source. All you need is a connector, and in the format, you will tell which connector to use. And then based on that connector supported options, you can tell additional information about your data set or your data source. Based on those information, the connector will start working, and it will read data and give you a data frame, right? So, and Spark comes with these type of inbuilt connectors. Anything beyond this, we will have to install the connector in our environment, and then we can use it. I'll show you one demo. So that's about the DataFrame reader. That's how we read the data, right? So hope you understand these two things. DataFrame APIs, it's a unified API, but then we also have shortcut methods. So if you come to this Spark session.read, and then go to DataFrame reader, you will see a standard method is to use format and then tell options. You can tell multiple options one by one using option method, like here, option, then next option, then next option, 10, 20, 30, whatever options you want to tell, you can tell that, or maybe options method to tell in a single call, right? That's all. The standard method is to tell the format, which tells which connector do you want to use for reading, and then tell option. What options do you want to set for the connector? That's all. Everything else is like shortcut method here. So we have everything, not everything else. I mean, this DataFrame reader also gives you some shortcut methods. Like for CSV, they created one shortcut method. For reading from the JDBC database, they gave a shortcut method. For reading JSON file, they gave a JSON shortcut method. For reading ORC file, they gave a ORC shortcut method. For reading Parquet, they have a shortcut method. For reading text, they have another shortcut method. But all these shortcut methods are not required. You can read everything using standard API. I have one example here to use the shortcut method, so you know how to use shortcut method. So basically, spark.read will give us DataFrame reader, and then we can use one of the shortcut methods. And put a dot, and then it should show you the list of methods. So if you want to read CSV, you can directly use CSV for shortcut method. If you want to read from a relational database, you can directly use JDBC shortcut method. And you want to read JSON, you can directly use JSON. We want to read CSV, so we are going to use the CSV method. And then CSV method takes everything as an argument. First thing is to tell the source location, and after that you can keep on telling all the options. I want to tell two options. Header is true, infer schema means automatically infer the data type from the data. So that's one way of reading. So this is shortcut method, not recommended. We recommend using this approach because that's a standard method, works for everything. So that's one thing I wanted to explain. You can also read data directly from these supported files or inbuilt connectors are also available to Spark SQL. The approach is you simply write select star from, tell the format or the connector name. For example, I want to read CSV file, so I will tell CSV. If I want to read JSON file, I can tell JSON. If I want to read Avro file, I'll tell Avro. If I want to read Parquet file, I will tell Parquet. But in this example, we have CSV file, so let's use CSV. Then put dot, and then in a pair of backticks, right? This is not a single quote. This symbol is not a single quote. It's a backtick. You can find it on your keyboard just below the escape key, right? It's a backtick. So in a pair of backtick, you tell the location, and you can directly read data from a file, create a data frame out of it. But this approach doesn't allow you to specify options. So if I'm reading invoices, you can see I'm not able to read it correctly. Column names are automatically picked up. Header is there, but Spark is not considering header because by default header is false, right? So in Spark, this is internally using Spark connector. Behind the scene, the code is running like this. Spark.read format CSV and load. These two, this approach doesn't allow us to specify options. So this is rarely used. But for data files that come with inbuilt schema, for example, JSON or Parquet files, this approach works perfectly fine. So that's one way to read. There is more better way to read directly data from files using Spark SQL using the read files function. But this is Databricks feature. Read files, I'm not sure if it is available in Apache Spark, but definitely it is, maybe I've not tested it on Apache Spark, but this is available in Databricks for sure. So read file allow you to tell the source, format, header, infer schema, all that options, right? So it is read files is a kind of Spark DataFrame reader API brought to you in Spark SQL. So you can use read files and directly read data from file, and that's the flexibility Spark brings, right? In SQL, if you want to write a SQL select star from, you must have data on the table, in some table, right? And you tell the table name or you tell the view name, and then you can query. But Spark brings you that flexibility. You can directly query from the file without requiring to create a table if you have that kind of requirement. But this is also a shortcut method, I would say, directly in Spark SQL. And this is your standard approach. So that's pretty much about DataFrame Reader API. Whenever you are reading different kind of data from different files, for example, from JSON file, if you want to read data from a JSON file, I would want you to know that this is the place where you can come and see what options are supported, right? So that you can handle complexities in your data source, right? For example, let's take an example of reading a JSON. So I have a JSON file here. I can show you. This is a JSON data file, and okay, I don't know why it is taking so much time, but that's fine. So this is what we have in the file. Only 3 lines. Each line is like one JSON record in itself, and you know that JSON is a key value pair. So this is key, this is value, this is key, this is value, this is key, and this is value. This is key, and this is value. So I have 4 columns here. The first column name is string, value is string 1. Second column name is int, value is 1. Third column name is array, and value is an array of 3 integers or numbers. Fourth column name is dict, and the value is a key value pair. And that's the beauty of JSON files. It allows you to have a complex data types, right? So we can have array, we can have dict. We will learn more about complex data types later. But how do I read the JSON file? You already learned it. Reading data from any type of source is done through spark.read.format, tell the connector name is JSON. It is inbuilt with Spark. And then in the load method, I tell the format source from where to read, and I can get a data frame and display it, and it works. And you can see results here. It is reading perfectly. Array column comes with an array, right? Dict column comes with a dictionary. Int column comes with 1, and int column are numbers. String is the column name. So Spark is reading it perfectly. But all sources or the all input data files are not so neat and clean, right? That's the problem. With CSV or with JSON, you will find different kind of files with different kind of complexities in it. For example, I have one file here. One file here. This is also a JSON file, but it is not as neat and clean as this JSON file. This is a good, well-structured JSON data file where each record is a valid JSON record. Each line contains only one record, and each record is contained only on a single line. Even if it is longer, each record. So it is well structured JSON data file. But I got one more JSON data file. It is like this. This is little different. So what do we have here? We have array. This symbol represents a JSON array in JSON. So we have a JSON file which has a one array. Inside array, we have multiple elements, and each element is a JSON record, right? So this is the first element. This is the second element, and third element is little broken, right? So this is the third element. So we have only three records here, but those three records are packed into an array, and they come as element of the array. And each element is not assured to be put on a single line. So first element is on a single line, second element is on a single line, but third element is a multi-line element. It's a well formatted JSON, right? So it's a single record, but record is broken into multi-line. So this is one kind of complexity that you can get in the data. I'm showing you a JSON example, but the point is that when you get data files, you may have a different kind of complexity coming in your data files. And if you see that those kind of complexities while working on your project, you have to look for options in the connector to handle those complexity, right? So let's go. I'm reading JSON. Let's go and look for the options, available options. How do I handle this complexity? So if you come to the JSON connector here in the documentation, look for the options. We have some. There are so many options here. Maybe there is one option called multi-line. By default, it is false. And if I set it true, then maybe my problem will be resolved, because multi-line allows parse one record, which may span multiple lines per file. JSON built-in function ignore this option, right? So built-in because default is false. So the problem that I have in this file is known as a multi-line JSON problem. With my experience, I know this is how a multi-line JSON record is represented. Everything is packed into an array, and then maybe some records are on a single line, but some records are broken down on to a multi-line. So this is a good multi-line JSON example. So how do I read it? If all I have to do, okay, tell the option multi-line equal to true, and I'll be able to read it correctly. Without this multi-line true option, you will see some garbage. Spark won't be able to read. You can see everything is read properly. You can see good data. But if I remove this option, and if I run this, you will see what happened. Okay, this is another problem. After this new line character, even if you have some spaces, it won't compile. You can see it's all coming like a garbage. It's saying corrupt record, all fields are null, records are thrown into corrupt record. It doesn't work properly, right? So because to connector, I'm not able to tell anything additional, and connector is not able to read it with the default configuration. So the point is that whenever you are going to read data from some source, look for the connector. Do you have inbuilt connector? Yes or no? If yes, great. Do you have complexity in the data file or format or in the source? Or do you need to specify additional information like username, password? Let's say you are reading from a relational database. You can provide the source detail format, but how do you provide username? How do you provide password? How do you want to provide additional information? Go look for the connector documentation. And inbuilt connector documentation is available here. You can come here and look for the available options and find which option is suitable for reading the complexity in handling the complexity in the data source, right? So that's what I wanted to help you understand with the DataFrame reader. Next thing is, what if the connector is not supported? Or let's say I have a data file here, which is an XML file, and XML is not listed here, right? We have everything, but not XML. So XML connector is not inbuilt with Apache Spark, not even inbuilt with the Databricks Spark. So XML connector is not there. But if I have to read an XML data file, how do I read it? I told you, method for reading data from any source is same, spark.read.format, and then you tell the options. But since XML is not supported, what I have to do, I have to look for the XML connector. Do we have an XML connector for Spark? If yes, we can read it. All I have to do is to install the XML connector in my environment and start using it. Maybe I'll have to look for the documentation and understand what the options are available. Do you want to read data from MongoDB? Approach is same. Do we have a connector? No, inbuilt connector is not there. So what I have to do, look for the connector, look for the documentation for that connector, how to install it in your environment and start using it. People keep on coming and asking, I want to read data from XLS file, Microsoft XLS file. I want to read data from PDF file. I want to read data from Word document. I want to read data from Twitter API. I want to read data from blah, blah, blah source, right? Can I read it or how to read it? Answer for all these questions is same. Check, do we have a connector available for Spark? Yes. Then look for the documentation for that connector. Read how to install that connector in your environment, install it, and then read the documentation to understand how to use that connector, what options are available, and start using it. That's all. So I have a problem here. Like I want to read XML file. I know connector, inbuilt connector is not there. So how do I go about it? So what I will do, I will go search if we have a connector for XML. So I'll go Spark XML connector, search for it. Oh, nonsense. And maybe the first one itself is good. In the GitHub, in the Databricks, I see a Spark XML connector. Let me go there. And I see it's created by Databricks, so maybe trusted one. I can trust. XML connector, it's available in Git. It's open source. Some documentation is available here itself. Lot of things are there. Example, how to use it, how to install it, everything is there. So in the linking section, you can say, see, you can link against this library. And this is group ID, this is artifact ID, and this is the version. So what it means, it is a Maven, it is available in the Maven repository, this connector, and I can install this in my environment using these details. So let's come and install it in our Databricks. In different environment, there are different approaches to installing additional packages and connectors. In Databricks, we are working in Databricks environment, so I'll show you in Databricks environment. In Databricks environment, also there are various approaches. We will learn more about it. But for quick approach, you come to your compute. This is my cluster, right? So when I say install this package in your environment, it means install this package in my cluster, right? So come to the cluster, come to the libraries, and you can install new library from here. So go to install new library. Where do you want to pull the package? I know it is available in Maven. So I come to Maven, and maybe I already know some details. Okay, this is my package name, artifact ID. Let's go in search packages from Maven Central. I search for these, so many, right? So maybe Databricks Spark XML 2.12, 2.13, 2.11, 2.10. These are Scala versions. So Spark XML for Scala 2.12, Spark XML for Scala 2.13, for Scala 2.11. There are 3 variants. Which one do I want to install? I want to install 2.12. Why? Because my Databricks environment cluster is based on Scala 2.12. I'll show you it in a minute. Which version I want to install? There are so many. Let's go with the latest. Select it. Coordinates are copied here. And if you see, this is same, right? com.databricks : Spark XML 2.12 : version. And that's what I saw here. com.databricks is the group ID. Spark XML 2.12 is the artifact. And this is the version, right? So we tell it here and hit the install button, and it will start installing. In less than a minute, it will be installed. So let it install, and then I will show you why I chose Spark XML 2.12. So that is standard. Whatever additional, while working with Spark, there are many times when you have to install additional packages, additional libraries, additional connector, all that is usual thing, right? So whenever you are installing or choosing which package to install, you have to make sure that package version is compatible with your cluster version or your Spark version, right? So if you come to compute, look at the cluster details, you will see that this cluster is running Databricks runtime version 12.2 LTS. LTS means long-term support. So 12.2 long-term support version, which comes with Apache Spark 3.3.2, Scala 2.12. So what I want to make sure is that whatever packages I'm installing are compatible with Scala 2.12. If I install a package which is compatible with Spark Scala 2.10 or 11 or 13, that might not work. So we have to make sure that it is compatible. So that's why I installed. Once I have the XML package installer installed, reading XML is as simple as reading anything else, right? Spark.read will give a DataFrame reader format. I'm telling connector is XML, and it automatically picks up from the XML that which connector do I need to pick up, right? And then options. So in option, I'm telling, okay, row tag is book. So what does it mean? You have to learn a little bit about options in the XML connector if you want to. There are so many. It's all listed here in features. So row tag is one option which tells in XML what represents a single row. one single record, right? So if you look at the my XML, XML is all about tags, right? So in my XML, I can see it is a catalog of books. In the catalog, everything is wrapped in the catalog from maybe top to bottom. And in the catalog, I have book, which starts from this tag and ends here, and a book, and then next book starts from here and maybe ends here, end book, then next book starts from here. So what it means, starting from book tag till the end book tag, I want to take everything, all of this as a single row. And in that row, I have author column, title column, this is the value, genre column, this is the value, price column, this is the value. So the bare minimum information that I have to tell XML connector is what represents a single row in my XML file. And that's what we are telling here, row tag, book, that's all. If you run this, it will go and read the XML file from here, and you can see all this are like well structured, right? Spark XML connector is smart enough to read all this correctly and pick up data. So it's that easy. In this notebook, we have some examples to reading ORC file, but approach is same. Read, format ORC, from where to read. We have a binary file, which is, you can read binary file also. You tell format, what is the format? It's a binary file. Content, binary file reader will give you four fields, right? Path, modification, time, length, and the content. So this is the file content, which looks like junk character or binary characters here, because this is a binary file format. So binary file format is inbuilt with Spark. You can read it. Spark comes with the image format also inbuilt, so you can read image file, right? You can read compressed file using the same approach. Even if your file is compressed, you can read it. And that's the one very beautiful thing with the Spark API is that you don't have to tell the compression encoder or decoder, right? All you have to make sure that compression encoder is installed, and then Spark will automatically detect that this is a compressed file and how to uncompress it. For example, GZ compressed files encoder decoder is pre-installed on the Spark. So if you have a gzip file or a zip file or gz file or a snappy compressed file, all you have to tell, you don't have to tell anything. Spark will automatically detect what is the compression format used, and it will uncompress it. So in the format, you will tell what is the connector you want to use, not the compression format, right? So even if you are reading a compressed file, you will not have to tell the compression format. You have to tell what is the connector. So I know in this compressed file is internally a CSV file, so I'm telling connector here, and you can read the connected CSV file, compressed file also. So the point is that Spark DataFrame Reader API is the unified way of reading data from any source. All you have to have is a connector, and all you need to learn is the options available with that connector. I showed you some inbuilt connectors. I showed you one external connector, which we have to install explicitly. And in future, we will have some demos to see how to read from database, how to read from MongoDB, how to read from Cassandra. All those we can have. We cannot cover everything because the list of the connectors is huge. But the idea is that when you have a requirement to read data from a source in your project in Spark, you should know how to go about it, right? Look for the connector, install the connector, look for the connector documentation about options, and start using it. That's how we read data in Spark. So I think that's all about this session. I just wanted to help you point one more place. Basically, it is the same place. You go to Apache Spark documentation, latest documentation in the programming API, and the SQL data frames and data sets. This is the place where you will see Spark SQL documentation. And in data sources, you will see supported data sources. There are some generic file source options you should know. We don't use it a lot in real projects, but sometimes these are asked in the certification or in maybe in interviews. How do you handle this situation? So there are some generic options. These are nothing but options, right? So if you look at example, let's look at the Python. Maybe Scala code looks better to me to explain. Basically, Spark API is same. Whether you use Scala or Python, it's all same everywhere. Only rest of the language things will change. So how do we read data? How we are reading data here is spark.read.format. We are telling format is Spark A, and there is an option that I'm telling here in this example. This example is telling path glob filter, and filter is saying star.parquet, right? So this is a generic file option. So we have some generic file options to handle these situations. How do you ignore a corrupt file? How do you ignore a missing file? How do you apply a filter that read a wildcard filter while reading all files from a directory? Recursive file lookup and modification time path and filter. This one is good. So if you put that modified before option and tell the date and time stamp, read from this directory, then Spark will read only those files from this directory where modified date is files, those files that are modified before this date. So there are two options for file modification time path: modified before, modified after. Like that, I recommend you to go through these. Just know what options do we have available. They are not frequently used in real projects, but these are sometimes asked in certification questions or sometimes in interview questions also. So that's all about today's session.